Hello everyone, my name is Anthony, and today I'm going to be explaining two terms, pressure altitude and density altitude. We use them in aviation, but we don't really understand, I don't believe, people really understand what they mean. And I want to clarify what they mean and how to calculate both of them. So that's what I'll be doing now. Alright, so we're going to be starting with pressure altitude. Now, what is pressure altitude? Pressure altitude is an altitude. So, pressure altitude, in the simplest way I could say, is how the aircraft feels. It is the value that indicates how the aircraft feels pressure-wise. Now, I'm going to write down an equation. I'm going to explain that to you. So, there's an equation that will calculate this for us. And I'll explain to you how we interpret it. So, pressure altitude, it's a number, is equal to your current altitude plus ISA minus QNH times 30. Alright, altitude is an input altitude. ISA is always 1013. It's my quick way of saying 1013. QNH is your QNH, or your pressure at your altitude, so where you are. For instance, if you're on the ground and the ATIS says the pressure is 1015, then here you would put 1015. And 30 is 30. Alright, so let's say, I'm going to give you an example. Let's say, okay, example 1. Oh my diddly. Example 1. Example 1. So let's say we have a QNH of 1019, and my altitude is 60 feet. Okay, so I'm in Australia, and I did some flying training in Archfield. I know their altitude is about 60 feet, roughly. It's probably 65 or something. Okay, I want to know my pressure altitude. Okay, so let's get straight to the equation. I want pressure altitude. Let's start with the equation. Pressure altitude is equal to this. What do I know? I know my altitude, 60 feet. By the way, that's in feet. ISA, 1013. We already know that. QNH is 1019. Tick. That's all I need. Sweet, so I can calculate it. Altitude is 60 feet plus ISA, it's always 1013. QNH, 1019 times by 30. Just doing some math. 1013 minus 1019, that's 6. Negative 6 times by 30. 60 plus negative 6 times 30, that's negative 180. 60 minus 180 is negative 120 feet. Alright, so what does that mean? Okay, our altitude is 60 feet, yes? Our pressure altitude is negative 120 feet.
Now wait up. I made a mistake here, so here's what you need to know. With the example I gave, we were on the ground at 60 feet, yes? For the conditions, our pressure altitude turned out to be negative 120 feet. Now let's say we're flying. This means our aircraft feels like it's flying at negative 120 feet. Or it makes sense to say it's 180 feet lower than our current altitude. Now this is a good result, and that's because lower flying brings denser air, and that is better for aircraft performance. So for pressure altitude, lower than alt, or altitude, is better. Cool.
Hello everyone. This is the second part of the video, which is density altitude. So, density altitude includes these things. It includes outside air temperature, pressure altitude, And, well, that's really about it, but there's actually a little bits that go with it. Anyway, to get straight to the point, you're probably wondering what the equation is. There's actually three forms. I'll start with the first form, and then I'll show you the two variants. Density altitude is equal to pressure altitude, and then you plus OAT minus 15 minus 2PA 1000. Yes, I know it sounds a little long-winded, close bracket. And then you multiply the last bracketed thing, this one here, by 120. And that will give you density altitude. That's the full equation. Now, I memorized that when I was doing exams and stuff. Up to you. The second one is this. It's pressure altitude again, plus. And then this time, this whole bracketed thing, well, you can actually call that ISA deviation. And then you just multiply that by 120. Yep. So if you know your ISA deviation, you can skip all this, just do that. And the last form is this one. It is the outside air temperature, so in brackets, ISA outside air temperature, or just temperature, minus your temperature in ISA. Then that's multiplied by 120. Okay, so I'll get straight to example questions. Example 1. Alright, I'll start with this example. We're 1,000 feet. The temperature there is 25 degrees Celsius, and the QNH stated is 1007 hectopascals. Alright. Now, if you see these equations, you're probably going to be wondering which one. Well, I don't see anything about standard ISA deviation or temperature ISA. So those are your cues. If you don't see anything about temperature ISA, anything about ISA, then go straight back to the original one. So I'm going to do that. I'll write it out. 15, 2PA, 1000. By the way, I do memorize this. Yes. Okay. Alright. So, what do we know? We know OAT. Great. Pressure altitude. Well, I mean, there is no value right now for pressure altitude. But we know pressure altitude is the equation, don't we? Remember, it is altitude. So I'll bracket this in square brackets. Altitude plus ISA minus QNH times 30. So that's the PA. And then you add the rest. We'll work out the rest later. Do we have everything for it? We got ISA, we already know that. Altitude we know, we're given. QNH, we're given. So yeah, we satisfied what we need for PA, which means we can work that one out. No other variables. No. So we can work out DA. So I'll just draw it out. 1000 plus ISA 1013 minus QNH 1007 times by 30, and then plus this stuff. Temperature 25 minus 15 minus 2, and it's whatever the square bracket stuff is. So I'm just going to go square bracket dot 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 on 1000. You know what it means. So you can do that in the exam as well, as long as you answer it. That's cool. If there is an exam you're using, I don't know. Okay. Eventually you'll get to an answer. Yep, I can guarantee you that. You get to an answer, everything's numbers, so become a number. Alright. But what does that mean? That answer, what does that mean?
My explanation here wasn't the best either, so here's my short correction. For a density altitude situation, aircraft performance is better when density altitude is lower than pressure altitude.
So there you go.
Those are the basics to pressure and density altitude. To learn more on this topic and other topics in aviation, go visit gaviationconcepts.com. It's completely free, hassle-free. In other words, no sign-ups, no ads, just a good news website built just to clarify aviation topics such as this one. Don't forget to thumbs up if you enjoyed the video, and comment if you'd like clarification or wish to add some suggestions. See you next time.